Hello, so in this 15C we'll begin with models, and there'll be a couple of videos on models. So we want to have an way of interpreting our language, and in chapter 2 we introduced truth tables for our language, and that interpreted all of our language so far as we needed to of the chapter 2 language. So now we're in chapter 3 and we want to think, well, how do we interpret our chapter 3 language? How do we give meanings to the symbols? And you might think, well, and how can we state their truth conditions? And so you might think, well, let's do truth tables. We did truth tables for in chapter 2. Maybe we can do truth tables in chapter 3. So you might think, well, maybe this would be a truth table. So let's say we have fa and some x fx and for all x fx. Then suppose we say that fa is true. What is the truth value of some x fx? Well, it's true. If fa is true, then there's a thing that's f. But is for all x fx true? It's indeterminate. Maybe it's true, maybe it's not. It depends on whether or not there's something besides a, and if there is, whether or not that other thing or things are frogs or not. If all of them are, then for all x fx is true. But if some of them aren't, or if there's no other thing, then for all x fx is true. If there are other things, but they're all frogs, for all x fx is true. But if there are other things, and some of them aren't frogs, then for all x fx is false. So the point here is that by itself, the truth value of fa doesn't fix the truth value of for all x fx. For all x fx could be true, or it could be false. Or suppose fa is false. Well, is some x fx true? Who knows? Again, it depends upon whether or not there's anything besides a, and whether or not any of those other things are frogs or not. If a is the only thing, if there's nothing besides a, then some x fx is false. If there are other things, but none of them are frogs, then some x fx is false. But if there are other things, and at least one of them is a frog, then some x fx is true. So the fact that fa is false doesn't tell us whether or not some x fx is true. If fa is false, then for all x fx is false, because it's not the case that everything is a frog, because Alfred isn't. Okay, so fa by itself doesn't tell us whether or not some x fx or for all x fx is true. And so this is a general problem. Assigning truth values to atomic sentences doesn't fix the truth values of quantified sentences. Why? Well, because among other things, it doesn't tell us which things there are. And so it doesn't fix their truth values. If you could say, here's a really long list of things that are f, but if you don't know whether or not that's the complete list, you don't know whether or not some x fx is true. And if you say, here's a long list of things that are not f, but you don't know whether or not that's the list, whether or not that list contains all the things, then you don't know whether or not some x fx is true. So you can't do truth tables for sentences of the monadic predicate calculus. They won't work. They're not the right kind of thing. So instead, we're going to have models. Models are what we have instead of truth tables. Or more precisely, models are what we have instead of truth table rows. So let's recall truth tables and their rows. So when we're building a truth table, we construct a truth table for a sentence. And then we have all the different rows. And what each row does is describe a different situation, the situation in which P is true and Q is false, say. And then we can figure out whether or not, then that's enough information to fix whether or not the sentence box is true. So for example, let's say we have the sentence P if and only if R, then Q if and only if R. And so on each of the different rows of the truth table, we have a different combination of truth values for P, Q, and R. And then on each of those rows, the big sentence has one truth value. So for example, if we take a specific row, then we can ask, what truth value does P if and only if R, then if Q, if and only if R does. And on that row, so we assign a truth value to each sentence letter that occurs in our big sentence. And why do we do that? Well, we need to say enough about a possible situation, in particular, what the truth values are of the sentence letters in that situation, to fix the truth value of the sentence. So the point of a truth table row is this. We say we're going to describe a situation partially, right? Because here we have a description of a situation in which P is true, Q is false, and R is false. That leaves open lots of facts about the situation, like is S true or false, and so on. So we have a partial description of a situation, and we describe it with enough detail to fix the truth value of the sentence we care about, and with no more detail than that. So it turns out that what a model is going to do is just like what a truth table row does. The model specifies some facts. Which ones? Just enough to fix whether or not the sentence is true or false. In any situation that's like that, so the model's going to say, here's a description of a situation, partial, but we're going to know, but it's enough that we know that in any situation like that, either the sentence we care about is true or the sentence we care about is false. So it needs to do enough to tell us whether or not the whole sentence is true or false in that. So I've motivated models. I've said why we want to talk about them, but what are they? What are they? What is that information? Well, we'll see that in the next video.